Okay, I thought I'd just record a quick video for you to show you number 3 in the law of cosines, law of sines unit. Okay, so this is what you need to do. So first, just draw a sketch. Remember they said that Niagara Falls, I put the problem here, but it's super small. So Niagara Falls is due north of Orlando, so here's Orlando, and then each of them are a distance from Denver. And I certainly didn't draw this to scale, which you don't need to worry about as long as you just label your sketch. Okay, so I used law of cosines to find angle O. Okay, so now I guess you really could have found another one too. I just picked that one. You could have found angle N and done it differently, but still end up with the same answer. So anyway, what I did is I found angle O. So here's the law of cosines work. Okay, so notice angle O is on this side of the equation, and the side opposite angle O is on the left side of the equation. That's the main thing you need to remember. Okay, so you solve and you get cosine O is equal to 0.5246 approximately. Now, then you do second cosine, decimal, and you get 58.356 degrees. Okay, so that's this right down here. Now, what you need to do is realize if you're working with problems of navigation, you find the direction from due north, which is called a bearing. Okay, so that's why I drew this right here. This theta is marking the direction of the plane, okay, from Denver to Orlando. So you just draw a little coordinate axis right at Denver and then measure from the north all the way through to the line that takes you to Orlando, okay? So along this line right here. Okay, so now let's think about it for a minute. All we know from here to here is 90 degrees. That first quadrant right there. I can't get my pointer to move here. Let's see if I can do it. There we go. So from there to here, right where the dashed line is 90 degrees. So really all we need to know is what little part of the angle is left over. Okay? So what I did is I came down here. We found angle O. I drew a coordinate axis at angle O, and I know because Orlando is due south of Niagara Falls, it said in the problem, so I drew a coordinate axis, and that is a right angle there, so therefore I know that this angle right here is 31.64 degrees approximately. I rounded there. Okay, now because of this is bringing back some geometry, alternate interior angles tells us that if this is our transversal, let me point to it, this is our transversal, then this angle right here, that little one, and this one are going to be congruent because they're alternate interior angles. See, here's my horizontal line, and here's the horizontal line up here. They are parallel to each other. This is a transversal that is cutting that, cutting through those two parallel lines. Okay, so if this is down here is 31.64 degrees, then this little one is here, and obviously I haven't drawn it to scale. So anyway, that little angle is there, so all you had to do was, and by the way, I did show the work over here, I just found the complement of 58.36 by subtracting it from 90 and getting 31.644. Okay, and so then you have to come over here and say, well, the 90 degrees from here to here plus this little angle we just found to be 31.64 degrees. When you add those up, you get 121.644, and they said 121.7, but I rounded in the middle of my problem, but that is how you find the answer. So anyway, you are using alternate interior angles, and when I said earlier that you could have found another angle, you could have drawn your coordinate axes up here too and found alternate interior angles using that angle. So, I mean, there's different ways to do the problem, so it's not like you only have one way to do it. But this is the way I chose to do it. Okay, so let me know if this didn't help enough, and that's what you need to do. But just remember, when you're doing navigation problems, angles are measured from due north. And the reason that is think about it, when you're navigating, you're using a compass, and a compass, you want to orient yourself to due north. So that's where that comes from. Okay? All right, I hope that helps. Let me know if you still have questions.